Hello friends, once again welcome to our this new video. This is the video number 16 based on the topic solutions. In this video we are going to learn the concept of osmotic pressure. So this osmotic pressure can be explained well with the help of an experiment that is called as Abbe Nollete experiment. See, this experiment consists of a long stem thistle funnel or long neck thistle tube. The mouth of this thistle tube is closed with a semi-permeable membrane such as animal bladder or pig's bladder. Then the solution such as sugar or sucrose solution is filled inside the thistle funnel or this tube. Then overall tube is placed inwardly into a pure solvent such as water inwardly. That is what this thistle tube is then placed inwardly or with inward position into this pure solvent or water like this. Then what happens? The pure water, that is solvent, and the sugar solution, this is separated by the semi-permeable membrane, and that's why the phenomenon of osmosis occurs, that is the flow of solvent molecules from this pure solvent water to the thistle funnel or inside this sugar solution occurs. What is that? The net flow of solvent molecules into the sugar solution occurs. As a result of that, the liquid level in this tube, or in this case the liquid level rises in the tube, and that is a liquid column. Now this liquid column exits the pressure over this sugar solution. So therefore what happens? This external pressure or this excess pressure stops the incoming molecules. That is, this external pressure, that is called as the hydrostatic pressure. This excess pressure or this external pressure, this is also called as excess mechanical pressure. So this excess pressure stops the osmosis and it forces to solvent molecules from this sugar to pass into the solvent, that is, and reverse process starts. So when there is an equilibrium between the solvent which comes inside this thistle tube and the molecules from the solvent which force back reverse into this solvent. So when an equilibrium is exists there, so at that time the level of this liquid in the column is constant, and at that time whatever may be the pressure that is exerted by this liquid column over this solvent which is responsible to stop the process of osmosis. So this is called as hydrostatic pressure. So such a way that what is the hydrostatic pressure? Try to understand. So this is the excess pressure which is because of this liquid column which stops the phenomenon of osmosis or the process of osmosis. This external pressure or this excess pressure is called as hydrostatic pressure. So when this hydrostatic pressure becomes equal to this pressure of the solvent molecules, then at that time, so this is called as the osmotic pressure. What is that? The hydrostatic pressure which is enough to stop the flow of the solvent molecules into the solution, that is to stop the osmosis, that is called as the osmotic pressure. So this osmotic pressure, we have to note that it is important that, so this osmotic pressure is not the pressure of the solution, is not the process of the solution, but this osmotic pressure exists only when the solvent and solution are separated by the semi-permeable membrane. So that is during the osmosis. So that is what the osmotic pressure. So see, in this case, with the help of this, by measuring the hydrostatic pressure, that is the excess mechanical pressure, it is possible to determine the osmotic pressure. Then one more simple aspect related to this. So depending upon the osmotic pressures of the solutions, solutions are of three types. So that is what types of solution based on the osmotic pressure. The solutions, those having the same osmotic pressure, are called as the isotonic solution. So these are the important terms which are used in this case. That is what the types of solutions based on the osmotic pressure. Any two solutions having the similar osmotic pressure are called as isotonic solutions. For example, the solution of sucrose and solution of urea, if they having the same similar concentrations, that is 0.1 molar sucrose solution and 0.1 molar urea solution, both solutions having the molar concentration same, even though the concentrations in grams per liter are different. So such solutions having the same osmotic pressure, and therefore these solutions are called as the isotonic solutions. The second one is the hypertonic solution. The solution which is having the higher osmotic pressure than that of the other are called as hypertonic. So remember, the solution which is having the higher osmotic pressure than that of the other. So if in this case sugar or sucrose solution having the higher osmotic pressure than the urea, then that is called as the hypertonic. And the third type, hypotonic, the solution which is having the lower osmotic pressure is called as hypotonic. So compared to in case of sugar solution and urea solution, if the urea solution having the lower osmotic pressure, at that time that is called as the hypotonic solution. So in this way, with the help of this depending upon the osmotic pressure of the solution, solutions are of three types. So what is that? What we learn in this video, that is the concept of the osmotic pressure can be explained well with the help of this Abbe Nollete experiment. So please watch the video, and if you like, don't forget to subscribe it. So we stop here. Thank you.